Assalamualaikum. My name is Maznida binti Mazaini. I am from the Faculty of Science and Mathematics and I'm studying in Computer Science course which is the code is CS110. Today my group and I will present one of the topic in calculus which is application of differentiation. Before we start the presentation, let me introduce my group members. The first one is Azliza binti Azmarul Saidi. The second one is Durani Afiq bin Saidi. The third one is Nur Sarah Aisyah binti Abdul Malik. The next is Nur Syafiqah binti Razwan. The last one is myself, which is Masnida binti Mazaini, whose ID number 2008479772. Before I explain the small topic we choose in the main topic, I will explain the main topic first. Differentiation. What is differentiation? Differentiation is a process of finding a function that output the rate or change of one variable with respect to another variable. When do we apply differentiation? We can use differentiation to determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive. A function is decreasing if its derivative is always negative. This is the small topic we choose to explain, which is relate rates. What is relate rates? Relate rates problem involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. This is example in relate rates, which is x equal dx and dt, y equal dy and dt. Also, implicit differentiation is often used. What is relate rates objective? The objective is to find the rates of change of one quantity knowing the rates of change of another quantity.
Okay, hello, Assalamualaikum. My name is Nur Syafiqah binti Razwan. So here I will take my part to present you about solving a problem in example 1. So let us solve the problem together. So the question is, air is being pumped into a spherical balloon at a rate of 5 centimeter cube per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeter. Okay, here as like you see in this slide, the first thing that we need to do here is to identify what information that we've been given and what we want to find. Before we do that, so let's notice that both of the volume of the balloon and the radius of the balloon will vary with time and so are really function of time. Okay, here we know that air is being pumped into the balloon at a rate of 5 centimeter cube per minute. This is the rate at which the volume is increasing. Recall the rate of change are nothing more than derivative, and so we know that V upon T equal to 5. We want to determine the rate at which the radius is changing. Again, the rate are derivative, and so it's like we want to determine. Note that we need to convert the diameter to a radius. Now that we'll identify what we want radius. Now that we'll identify what we have been given and what we want to find, we need to relate these two quantities to each other. In this case, we can relate the volume and the radius with the formula for the volume of a sphere. So we use the sphere formulas. Okay, As in the previous section, when we look at the implicit differentiation, we will typically not use the t part of things in the formulas. But since this is the first time through one of these, we will do that to remind ourselves that they are really functions of t. Now, we don't really want a relationship between the radius and the value. What we really want is the relationship between the derivative. We can do this by differentiating both sides with respect to t. In other words, we will need to do implicit difference on the above formula. Okay. Now we don't really want a relationship between the value and the radius. What we want is a relationship between the derivative. We can do this by differentiating both sides with respect to t. In other words, we will need to do implicit differentiation on the above formula. So, like the slide, we can see. Note that at this point we went ahead and dropped the t from each of the term. Now we all need to do is plug in what we know and solve for what we want to find. So we got an answer. So that's all from me. Thank you.
Hello everyone, so I will be explaining about example 2. Alright, so the question that we have been given is a 20-meter ladder is laying against the wall. The top slides down at a rate of 4 meters per second. How fast is the bottom of the ladder moving when it is 16 meters from the wall? So this pink line here represents our ladder, and it is moving in this direction because it's going down. So this is the top part and this is the bottom part. Okay, so now we regard up as being the positive direction in this question. So the relation between x and y is not this, that is a slight error. It is actually x squared plus y squared, which is equivalent to 20 squared. Okay, so now we will be differentiating throughout with respect to time, since the values of x and y depend on t. So for those of you that remember, for x squared and y squared, we will do implicit differentiation, and that way we will get 2x and 2y down here. So how do we do that? So x to the power of 2, the power that is accompanied by the unknown value, you put it at the front. So in this case for x, you put 2 at the front, and then you just write x as normal, and the power is 2 minus 1. So whatever power that the unknown has, you just minus it with 1. So this is how you get the implicit differentiation. So that's how you get 2x. And the same thing applies for y squared as well. So after you have gotten 2x and 2y, you divide those two with 2. So that's why in that working down there, you're only left with x. So you just you can cross out those, so that's why you're left with x multiplied with dx over dt plus y multiplied with dy over dt. So now for this, they actually left out a step. If you can see in the previous slide here, since we're trying to find the value of dx over dt, this one, they decided to move positive y multiplied with dy over dt to the right hand side of the working. The same thing goes with x. They also move that to the right hand side. So that's why in this side you get negative y over x multiplied with dy over dt, because here x is multiplied with dx over dt, but when you bring it to the right hand side of the working, it will become divide. And since that is a positive y multiplied with dy over dt, if you bring it to the right hand side, it will become negative. So that's how you get this one. So now we know dy over dt is equivalent to negative 4 because they mentioned it here in the sketch, this. And now we just need to know the value of dx over dt when x is equivalent to 16. So now how do we know, oh I'm sorry, so now how do we know x is equivalent to 16? Well, in the question it says when the ladder is when the ladder is 16 meters from the wall. So it means that there is a distance of 16 meters between the ladder and the wall. So this distance down here is the 16 meters. And if you notice the y, which is this, it makes a triangle. So that's why in this next step, uh, it says that we can use a Pythagoras theorem to find the value of y. But since we're not looking for the hypotenuse of the triangle, that's why we're using a minus instead of a plus. So 20 squared minus 16 squared in a square root is equivalent to square root over 144, which is 12. So y is equivalent to 12. So now you might be wondering what this is. This is essentially, they're using the y multiplied with the dx over dt plus y multiplied with the dy over dt. They're essentially using that form of the formula, which is fine. You can use that if you're feeling comfortable. But we could also use this one at the top. So if you use this one, it will become dx over dt, which is equivalent to, we know y is 12, so just write that negative. 12 over x is 16, so 16, and then multiply it with dy over dt is negative 4, so you will get 3 meters per second. Both of these forms will get you the same answer. That's all.
Now, let's look at another real-world example of related rates. We have a tank of water in the shape of a cone that's leaking water at a constant rate of 2 cubic foot per hour of water. The base radius of the tank is 5 foot and the height of the tank is 14 foot. The first question is, at what rate is the depth of water in the tank changing when the depth of the water is 6 foot? And the second is, at what rate is the radius of the top of the water in the tank changing when the depth of water is 6 foot? Now, the first thing we can do is to visualize our problem to understand them better. Here, we have an upside down cone with a base radius of 5 foot and a height of 14 foot that is leaking water at a constant rate of 2 cubic foot per hour of water. Note that we put a negative value to the 2 cubic foot per hour because our volume of water is decreasing over time. We can use the volume formula of a cone and assign it to the variable V. Before answering our question, we need to list all the information that we know. From this information, we can find out that our radius is when the depth of water is 6 foot. We can visualize our cone as a cross-section of a radius to get a triangle. From this triangle, we can find the ratio between the radius and the height. We can say that r over h equals to 5 over 14 and write our radius in terms of height or h. Let's get back to our question. For the first question, we need to find the rate of change of height of the water when the height is at 6 foot. We can label our rate of change of height as dh over dt. Next, we want to write the volume in terms of h. So we can use the volume formula and substitute our radius in terms of h that we have written before. We will get V equals to 1 over 3 pi times 5 over 14 times h to the power of 2 times h. And we will get 25 over 588 pi times h to the power of 3. Next, we need to find the derivative of volume with respect to time. We will write it as dV over dt and equals to 25 over 588 pi. Then we multiply it with the derivative of h cubed by using the chain rule, which we will get 3 times h squared times dh over dt. Since we already have our derivatives of volume with respect to time, which is dV over dt, and the value of h, we can simply substitute the value negative 2 and the value 6 into the equation. Negative 2 equals 25 over 588 pi times 3, which is 25 over 196 pi times 6 squared times dh over dt. By calculating it further, we will get negative 2 equals 225 over 49 times pi times dh over dt. To get the value of dh over dt, which is the rate of change of height, we need to move the rest of the equation to the right hand side, which then we'll get negative 2 over 225 over 49 times pi, which will then be simplified to negative 98 over 225 pi, or negative 0.138 foot per hour as the final answer. The negative sign shows that the height is decreasing in value. For the next question, we need to calculate the rate of change of radius when the height is at 6 foot. We will declare it as dr over dt. Since we already have our radius in terms of height earlier, which is r equals to 5 over 14 times h, we can simply find the derivative of r, which is equals to 5 over 14 times to the dh over dt for the rate of change of height. By using our previous calculation, simply substitute the value of negative 98 over 225 pi into the equation. Then we will get our answer, which is negative 7 over 45 pi, or negative 0.04951 foot per hour.
So, the conclusion that we can summarize from this topic is that there are several steps to solve related rate problems. Step 1. Identify the rates of change that are known and the rate of change that is to be found. Step 2. Construct a formula or an equation that relates the variable in step 1. Try to draw an appropriately labeled figure for it. Step 3. Differentiate both sides of the equation by using implicit differentiation. Step 4. Substitute all the known terms and values given in step 3. Step 5. Solve the unknown. That's all for the conclusion. Thank you.